Okay, so I am going to go over what we did on March 13th, and that is the beginning of trigonometry. So also called trig, sine, cosine, and tangent. But before I talk about that, I want to go ahead and take a look at how to label some of these right triangles. So I have a right triangle over here on the left. Notice that I've drawn attention to that angle in red. And from the perspective of this angle, I've gone ahead and I've labeled the sides of the triangle. So notice that I have opposite, adjacent, and hypotenuse. Now, the hypotenuse, that is only present in right triangles, and it is always the longest side, which can be found on the opposite side of the right angle. So I see the little right angle box. Straight across from it is the hypotenuse. And that will always be that longest side of a right triangle. But opposite and adjacent, they are relative to where the angle is sitting. So notice that adjacent is referring to the side that is attached to the angle, but is not the hypotenuse. So I can form this red angle here. The adjacent and the hypotenuse form that angle. If I go straight across to the far opposite side, that's why it's labeled opposite. I have another example on the right-hand side. Same right triangle. I have labeled my hypotenuse, but this time I've moved my red angle to be way up top. My angle is way up top here. The side adjacent is now this one up here, this vertical. And if I go straight across, the bottom is now my opposite. Analogy of opposite, adjacent, and hypotenuse when talking about ratios regarding trig functions. So this is what we started on that March 13th, that Friday right before we left. So these are functions, so they have an input, you can get something out. Notice up top here they have little parentheses. Those parentheses are telling you that something's going to go inside them, and we'll see examples of that in a little bit. Right now, I want you to understand that if I say sine, I'm thinking of the ratio of opposite over hypotenuse. So notice that S is for sine, O for opposite, H for hypotenuse. That's how I get SOH, S-O-H. I also have a cosine ratio, adjacent over hypotenuse, A over H. So CA, C-A-H. For tangent, I have opposite over adjacent, O over A, and that's where my TOA comes from. So when I say SO, CA, TOA, it's meant to be an acronym that helps you to remember these special ratios inside of right triangles. So this is where we left off. So I noticed that over here, they asked me to use angle A. So I've given a little dot for angle A. Remember that when we're labeling angles, we can use dots or arcs. Both are fine. So I have angle A sitting here. I then went ahead and I labeled my adjacent, my opposite, and my hypotenuse. So I had that right angle symbol, so I went ahead and said, okay, that longest side over there, that must be my H for hypotenuse. This side on the bottom, it is adjacent to my angle, so I labeled it with an A. And if I go straight across, that far side is my opposite, so I labeled it with an O. So then I'm coming through here and I'm trying to label my sine of A. I said, okay, well, what is sine? From SOHCAHTOA, S-O-H, opposite over hypotenuse. So the sine of A is O over H, 5 over 13. So that's the answer for sine of A. For cosine of A, stand at A. Cosine says CA, adjacent over hypotenuse. So we're going to do A over H, 12 over 13. 12 over 13. For tangent of A, we have opposite over adjacent, 5 over 12. So I find 5/12. That is the answer for this one right here. Notice for the next triangle, it is very similar. The side lengths are the same, but they told us to look at a different angle. They say this time, stand up top at angle B. So again, I can use a dot or an arc. Doesn't matter. I'm just labeling angles. Based on that new perspective, I'm go ahead and label your triangle. Well, the hypotenuse never changes. 13 is still my hypotenuse. What's flip-flopped is the adjacent and the opposite. So notice that if I'm standing at B, the side that is now directly touching me, directly adjacent to me, is the 5. That's why 5 is an A this time for adjacent. And if I start at B and go straight across to the opposite side, well then 12 is now the opposite. Well, let's go ahead and fill these in. Sine of B, so I'm standing at B, sine is opposite over hypotenuse, O over H, so 12 over 13. 12 over 13. Cosine is ka, adjacent over hypotenuse, adjacent over hypotenuse, so 5 over 13. Tangent, opposite over adjacent, 12 over 5. Go ahead and take a look at this bottom set. So this time, notice that they told us to use angle A. So I come to A, I put a little mark down so I know where to stand, and then I went ahead and I labeled the parts. So hypotenuse was opposite the right angle, so that's my H. The side directly touching angle A is this root 3, so I labeled a lowercase a next to it. And if I went straight across to the opposite side, that means this 1 must be O for opposite. So I go over here and I say, okay, let's go ahead and find sine of A. Standing at A, opposite over hypotenuse, 1/2. Cosine of A, adjacent over hypotenuse, root 3 over 2. Tangent of A, opposite over adjacent, 1 over root 3. Now do notice that right now there's a radical on the bottom. For the time being, that's perfectly fine. In the future, we might ask you to do something called rationalization, which means you'd get the radical out of the bottom. But for now, I'm not worried about that. Just make sure you can pick the correct parts and write it as the correct ratio. Use the exact same numbers in that triangle, but now do it from the perspective of angle B. So I started by labeling that angle up top. That's my angle B. And then went ahead and said, okay, well, my hypotenuse definitely did not change. It can't. Still opposite the right angle. The adjacent and the opposite, though, these are what flip-flopped. Remember that adjacent means next to. This side is adjacent to angle B, so it gets the A. If I go straight across, this bottom then is now O for opposite. So, if I want to find sine of B, I am using opposite over hypotenuse. O over H, root 3 over 2. I am doing cosine of B. Adjacent over hypotenuse, 1 over 2. If I am doing tangent of B, opposite over adjacent, root 3 over 1. Now, if I'm dividing by 1, that's just the same thing as whatever was in the top. So root 3 divided by 1 is just root 3. Now, something to notice is that when I mentioned how the opposite and adjacent flip-flop, it's the same triangle but a different perspective, this means that the sine and cosine are flopping. So come back up to here. Notice that sine of A was 1/2. Well, cosine of B was 1/2 also. Cosine of A was root 3 over 2. Sine of B was root 3 over 2. So if the triangles are the same, but I'm standing in a different spot, the sine and cosine just flip. I'm going to slide it to the right-hand panel now. We did the same thing up here, although on this side we had to have some simplification. So they said use angle A. So I put a mark down for angle A, a little arc angle symbol. I found my right angle, and I went ahead and went straight across to label the hypotenuse H. Then I came back to angle A, and I said, okay, 9 is the side adjacent to it, so it's lowercase a. Now if I go straight across, 12 is my opposite. So for the sine of A, I'm doing opposite over hypotenuse. That is 12 over 15. Now, I can reduce that. 12 and 15 are both divisible by 3. 12 divided by 3 gets me 4. 15 divided by 3 gets me 5. Do the same thing for cosine. Adjacent over hypotenuse, 9 over 15. And again, they're both divisible by 3. 9 divided by 3 gets me 3. 15 divided by 3 gets me 5. So 3/5 is the cosine of A. And finally, tangent. Opposite over adjacent, 12 over 9. Once again, they are both divisible by 3. 12 divided by 3 is 4. 9 divided by 3 is 3. So the tangent is 4/3. Take a look at this next one. This time, their reference angle is B. So I put a little mark up at B. Notice that across my right angle is the root 58. That is my H for hypotenuse. This vertical 3, that is adjacent to the angle. That is a lowercase a. And if it goes straight across to the opposite side, 7 is my opposite. So the sine of B, opposite over hypotenuse, 7 over root 58. Cosine of B, adjacent over hypotenuse, 3 over root 58. Tangent of B, TOA, opposite over adjacent, 7/3. This next one says, stand at angle A. So here's my mark for angle A. I labeled my hypotenuse. I labeled my adjacent side. I labeled my opposite side. So the sine of A, opposite over hypotenuse, that is 16 over 34. I realized that they're both even numbers, so I divided by 2. 16 divided by 2 is 8. 34 divided by 2 is 17. So 8/17 is the answer for sine of A. For cosine of A, that's ca, adjacent over hypotenuse, 30 over 34. So I start with that, and once again, they are both even numbers. 30 divided by 2 is 15. 34 divided by 2 is 17. So 15 over 17 is the answer for the cosine of A. Now do tangent. Opposite over adjacent, 16 over 30. Same deal, divide top and bottom by 2. 16 divided by 2 is 8. 30 divided by 2 is 15. And finally, for this bottom one, they say look at angle A. So there's my angle A. That's my right angle. So going straight down, this is the hypotenuse. Remember, hypotenuse is always opposite the right angle, regardless of how your triangle has been rotated. So if I'm standing right here, this side here is my adjacent, and I go straight across. This side over here is my opposite. So to find the sine of A, opposite over hypotenuse, 1 over root 2. Cosine of A, adjacent over hypotenuse, also 1 over root 2. And then finally, tangent of A, opposite over adjacent, and 1 divided by 1 is just the number 1. So let me go ahead and draw attention to some things on the next page here. So again, I have the acronym up at the top, and I want you to notice that if I say to use sine, cosine, and tangent, it means that we're going to be talking about side length. So we're finding those values, it means find side length. If I do something else called arc trig or inverse trig, see this little -1 up top? In the terms of trig functions, this means inverse. And you're going to be using these to find angle measures. And that's going to come near the end of this section. Right now, just know that there'll be 2 different things, one to find sides, one to find angles. Now what I have down here are some common abbreviations. The actual spelling of sine, cosine, and tangent are these 3 right here. But when we abbreviate them, like you might see on a calculator, we write them like this. It's also how we do it when typically solving a question by hand. That way we don't have to write out the full words. Similarly, adjacent becomes ADJ, opposite OPP, hypotenuse HYP. Now, the hypotenuse is always opposite the right angle. It is always along the side. And this process of using SOHCAHTOA will only work for right triangles. And basically everything in this packet here is all about the right triangle. So right, on this page here, I have some examples of those ratios, just like I started with. The sine and cosine are found by doing opposite over hypotenuse and adjacent over hypotenuse. The tangent is the opposite over the adjacent.